Hello and good day. This is our BioStatistics PBL on the topic, is there a difference in the mean systolic and diastolic blood pressure of males and females? The reason why we are doing this research is to determine which gender requires more medical attention. For example, if a particular gender is more prone to high blood pressure, we will know which gender to administer medication or advise for more frequent medical checkups. The droplets here represent blood pressure. We'll be analyzing on the steps as to show whether there's a difference in the blood pressure of males and females. Firstly, we'll find out what type of data or levels of measurement our research question actually falls into. As you know, the levels of measurement includes nominal, ordinal, interval, and ratio, each building up upon the previous. Since this is covered in previous lessons, selecting the nominal level appears to be appropriate in our situation, where you can't really place genders in an order or genders cannot really be ranked. Here I will go through some terms used in our research. I'm sure you have already heard of this, but I'll go through this briefly as a recap. First off, we have the mean, which pretty much means the average of something, usually a set of results. Up next we have the mode. Mode is defined as the value that occurs most in a set of data. In this case, we'll be using rainfall for an example. Each droplet represents a specific unit of rainfall. For each day of the week, the rainfall is recorded. As we can see, 4 droplets show up more frequently, hence the mode is equal to 4. Then we have the median. Median is simply the middle. Here we have 5 guys. The middle of them would be the third guy from the left. Do note that the median is calculated only when the data is arranged in ascending order. Here we have the standard deviation. It shows how much a particular value deviates from the mean. Here we have 3 guys, arranged from the shortest to the tallest. We'll take the mean height to be the middle dude at 1.7 meter. The difference between the first guy and the mean is 0.2. Same goes to the difference between the third guy and the mean. Standard deviation can be calculated by finding the average. A high standard deviation indicates that the data is spread out. SD can also be denoted as sigma. Finally, we have variance. It is just simply the square of the standard deviation, and it measures how far a set of numbers is spread out. This graph is plotted using the given dataset. Before we dive into this, I need to explain more about central tendency. Central tendency is a measure of the location of the middle of a distribution. By finding mean, mode, or median, one can determine the central tendency. But which to choose? Mean works best when the shape of the distribution is rather symmetrical. That means little or no skewness, with low amount of outliers. The median works best when there are outliers and a significant skew. The mode can only be used in a qualitative data. This graph depicts the data set for males. As you can see from the graph, the mean and median is very close together, but the mode is far off at 135. This is because mode is only accurate when used in a qualitative data. In our case, it is quantitative. So let's take a look at mean and median. We have only 2 outliers, but our distribution is not that skewed, hence median is out. The histogram depicts a rather symmetrical distribution, therefore it is safe to use mean. Up next, we can use the range, interquartile range, variance, standard deviation, and coefficient of variance to measure dispersion, which refers to how stretched a distribution is. Our distribution is symmetrical and has outliers, hence the coefficient of variance is most desirable for use in our case. It is calculated that the coefficient of variance is 0.10996 or 0.11 for males. Here is the graph constructed using the female dataset. Although it appears positively skewed, the standardized skewness is 1.588. Therefore, it can be considered rather symmetrical, and the mean will be used to measure central tendency. We use the coefficient of variance to measure dispersion for the same reason, that is, it is quite symmetrical with little or no outliers. The coefficient of variance for females is 0.1618 or 0.16. This is larger than that of the male, which is 0.11. There isn't a significant difference though, therefore it is safe to assume that the measurement of dispersion for both male and females is roughly equal. Here we have a box plot. Our goal is quite similar, that is to determine how best to go about finding the measurement of central tendency. The female box plot, the red one, appears to be slightly positively skewed, while the male box plot appears to be symmetrical. Once again, there are only 2 outliers for the males. Roughly symmetrical and low amount of outliers, this is why we shall use mean as a measurement of central tendency. One thing to note is that the mean, as well as right whisker of the female box plot, is further than that of the male. However, we cannot go about assuming that the females have a higher blood pressure than males. Further analysis is required, bringing us to the next part of this video.
Firstly, there are 2 types of error, type 1 error and type 2 errors. Type 1 error is known as false positive. So what exactly is false positive? A scientist goes on a hunt for rare turtle's egg. He found a pile of eggs and thinks that it is the egg of a rare turtle. However, in actual, the eggs belong to an ordinary turtle. This error is what we call a type 1 error or false positive. Type 2 error is known as false negative. So what exactly is false negative? A scientist goes on a hunt for rare turtle eggs. However, this time, he found a pile of eggs and thinks that it were not the eggs of a rare turtle. However, in actual, the eggs belong to a rare turtle. This error is what we call a type 2 error or false negative. In our context, a type 2 error is more detrimental to our study as compared to a type 1 error. If we have a type 2 error in our study, it means that we think that there is no difference in the mean systolic and diastolic blood pressure, when in actual fact there is. This completely contradicts our main aim of our study, which is to administer drug on the gender that has a higher blood pressure. Now we will proceed with hypothesis testing. Our null hypothesis is that there is no difference in the mean systolic and diastolic blood pressure of males and females. Our alternate hypothesis is there is a difference in the mean systolic and diastolic blood pressure of males and females. Our null hypothesis prime is that the variance of male blood pressure and the variance of female blood pressure is the same. Our alternate hypothesis is that the variance of male blood pressure and the variance of female blood pressure is not the same. Now for the test of 2 variances. The level of significance is at 5%. The sample size for both male and female is 50. The standard deviation for male is 20.019 and the standard deviation for female is 23.192. The variance for male is 400.769 and the variance for female is 537.862. The ratio of variance is 0.745. This is also our F statistics. There are 2 ways for us to know if we should reject our null hypothesis. The first way is by using the upper and lower fence. The lower fence is 0.423 and the upper fence is 1.313. All these numbers is obtained from the MinuteStats. As our F statistics is in between the 2 fences, therefore our null hypothesis is not rejected. Another way is by looking at the p-value. This is also obtained from the MinuteStats. Our p-value is 0.306. As our p-value is bigger than our level of significance, which is 0.05, therefore the null hypothesis is not rejected. Now we are back to our initial step, and that is the for hypothesis. Since our null hypothesis is not rejected, it means that the variance of both male and female blood pressure is the same. This will bring us to the final step of hypothesis testing, and that is to test if the mean of both female and male blood pressure is equal. Now for the test of means. The level of significance is once again at 5%. The sample size for both male and female is 50. The mean for male is 131.9 and the mean for female is 143.3. The standard error for male is 2.8 and the standard error for female is 3.3. Output SD is 21.6637 and the estimated difference is negative 11.42. There is also 2 ways for us to see if we should reject our null hypothesis. The first way is to look at the critical region. Our degree of freedom is 98 and our t-stats is minus 2.64. Our t-crit value is plus minus 1.98. As our t-stats is inside the critical region, therefore the null hypothesis is rejected. Another way is by looking at the p-value. Our p-value is 0.010. As our p-value is smaller than our level of significance, which is 0.05, Therefore, the null hypothesis is rejected. Our power for our hypothesis testing of mean is 0.74. This is once again obtained from the MinuteStats. This means that there is a 26% chance of us having a type 2 error in our hypothesis testing. In order to obtain the power that we want in this case, which is 0.90, we must have a minimum sample size of 77 for both our samples. In conclusion, females have a higher blood pressure than male. With this, we would recommend that females go for a regular health checkup in order to monitor their blood pressure.